Welcome to Selection with Sathi. Today we cover tree DP and counting problems. These are some of the most challenging and elegant tree problems. We will learn maximum path sum with negative values, counting nodes in a complete binary tree in O of log squared n, checking if one tree is a subtree of another, counting the number of structurally unique BSTs using Catalan numbers, and converting a binary tree to a doubly linked list. Let us begin. Maximum path sum in a binary tree. The path can start and end at any node and does not need to pass through the root. Look at line 6. For each node, compute the maximum gain from the left child. We use max of 0 to ignore negative contributions. Line 7, same for the right child. Lines 9 and 10, the path sum through this node as a turning point is node value plus left gain plus right gain. Update the global maximum. Line 12, but when returning to the parent, we can only extend in one direction. Return node value plus the max of left or right, not both. This is the key insight. The turning point stays local, the return goes single direction. Counting nodes in a complete binary tree can be done in O of log squared n instead of naive O of n. The key observation, in a complete binary tree, either the left subtree or the right subtree is a perfect binary tree. Look at lines 4 and 5, compute left height by going all the way left and right height by going all the way right. Line 7, if they are equal, the tree is perfect. Count is 2 to the h minus 1. Lines 8 and 9, otherwise, recurs on both subtrees. At each recursion level, one subtree will be perfect and terminate in O of log n total, O of log n levels times O of log n height computation each gives O of log squared n. Checking if tree B is a subtree of tree A. We need two helper functions. Is same, starting at line 9, checks if two trees are structurally identical. It compares values and recursively checks left and right children. Is subtree, at line 1, tries to match B starting from every node in A, line 4. If A and B are the same tree, return true. Line 6, otherwise, recursively check if B matches any subtree of a dot left or A dot right. The worst case time is O of m times n, where m is the size of A and n is the size of B. A more efficient approach serializes both trees and uses string matching. How many structurally unique BSTs can be formed with n keys? The answer is the nth Catalan number. The idea, choose each key from 1 to n as the root. If root is I, the left subtree has I minus 1 keys, the right has n minus I keys. The number of left BSTs times the number of right BSTs gives the count for that root. Sum over all root choices gives the total. Look at line 5, for each possible number of nodes, try each as root. Lines 6 and 7, left count and right count. Line 8, multiply and add. The first few Catalan numbers are 1, 1, 2, 5, 14, 42. Gate directly tests these values. Converting a binary tree to a doubly linked list in Inorder sequence. The left pointer becomes the previous pointer, right becomes next. Look at line 8, perform Inorder traversal. Visit left subtree first. Lines 9 through 11, if there is a previous node, link previous dot right to current and current dot left to previous. Lines 12 and 13, if there is no previous, this is the head of the DLL. Line 14, update previous to current. Line 15, then visit right subtree. After traversal, head holds the leftmost node, smallest in BST. This is in place. No new nodes are created. Time is O of n.
Let us trace max path sum on tree, root -10, left child 9, right child 20 with children 15 and 7. Node 9 is a leaf. Left gain 0, right gain 0. Path sum through 9 plus 0 equals 9. Return 9. Node 15 is a leaf. Path sum 15. Return 15. Node 7 is a leaf. Path sum 7. Return 7. Node 20, left gain is max of 0, 15 equals 15. Right gain is max of 0, 7 equals 7. Path sum through 20 plus 15 plus 7 equals 42. Global max is now 42. Return 20 plus max of 15, 7 equals 35. Root -10, left gain is max of 0, 9 equals 9. Right gain is max of 0, 35 equals 35. Path sum, -10 plus 9 plus 35 equals 34. Less than 42. Global max stays 42. Answer, 42. The optimal path is 15 to 20 to 7, avoiding the negative root. Complete binary tree with 6 nodes, root 1, left 2 with children 4 and 5, right 3 with only left child 6. At root 1, left height is 3 by going 1, 2, 4. Right height is 2 by going 1, 3. Not equal, so recurs on both subtrees. At node 2, left height 2 by going 2, 4. Right height 2 by going 2, 5. Equal. This is a perfect subtree. Count is 2 squared minus 1 equals 3. At node 3, left height 2 by going 3, 6. Right height 1 by just 3. Not equal, recurs. Node 6, left height 1, right height 1. Equal, count is 1. Right of 3 is none, count is 0. Total, 1 plus 3 plus 1 plus 1 plus 0 equals 6. We only computed heights a few times instead of visiting all 6 nodes. Is tree B equal to 4 with children 1 and to a subtree of tree A equal to 3 with left 4 having children 1 and 2, and right 5? Call is subtree of a rooted at 3 with B. Check is same of 3 and 4. Values differ, 3 not equal to 4. Not the same tree. Try left subtree, is subtree of node 4 with B. Check is same of 4 and 4. Values match. Check is same of 1 and 1. Match. Left and right of 1 are none and none. Match. Check is same of 2 and 2. Match. Left and right of 2 are none and none. Match. Is same returns true? Yes, B is a subtree of A. It matches at node 4. How many unique BSTs can be formed with keys 1, 2, 3, 4? Base cases, dp of 0 equals 1, empty tree, dp of 1 equals 1, single node. dp of 2, root 1, left 0, right 1. dp 0 times dp 1 equals 1. Root 2, left 1, right 0. dp 1 times dp 0 equals 1. Total dp of 2 equals 2. dp of 3, Root 1 gives dp0 times dp2 equals 2. Root 2 gives dp1 times dp1 equals 1. Root 3 gives dp2 times dp0 equals 2. Total dp of 3 equals 5. dp of 4, root 1 gives dp0 times dp3 equals 5. Root 2 gives dp1 times dp2 equals 2. Root 3 gives dp2 times dp1 equals 2. Root 4 gives dp3 times dp0 equals 5. Total, 5 plus 2 plus 2 plus 5 equals 14. The fourth Catalan number is 14.
Quick exam tips for tree DP and counting. First, max path sum, return single side gain upward. But at each node, check the both sides path as a turning point. Ignore negative branches with max of 0. Second, count nodes in a complete binary tree. If left height equals right height, it is a perfect subtree. Use 2 to the h-1 formula. Total complexity is O of log squared n. Third, Catalan numbers count BSTs, valid parentheses, and many more structures. Memorize C of 3 is 5, C of 4 is 14, C of 5 is 42. Fourth, tree to DLL uses Inorder traversal. Left pointer becomes prev, right pointer becomes next. In place, O of n. That covers tree DP and counting problems. These are some of the toughest tree problems, but with practice the patterns become second nature. For more DSA concept videos with code walkthroughs, download the Selection with Sathi app. Like and subscribe. Thank you.